When people debate ideas, they go back and forth with their statements. One person saying something, the next person trying to refute what the first person said. And it can be really interesting to figure out whether what one person says is the truth or is it a lie. We can use logic to figure out whether a statement is true or a lie by using truth tables. To determine whether or under what circumstances statements are true or false, we're going to use some basic truth tables for negations, conjunctions, disjunctions, conditionals, or biconditionals. Let's look at an example to see how we can build a truth table to determine whether a statement is true or false. The statement we'll be looking at is, if I can't get a loan, then I won't buy a car. The first thing we'll do is look for the simple statements that make up this statement. I can't get a loan is a negation of I do get a loan, so we'll let P represent I get a loan. That means I can't get a loan would be not P. The other simple statement we can find comes from I won't buy a car. That's a negation of I buy a car. So if Q is I buy a car, I won't buy a car is not Q. The entire sentence is a conditional statement, an if-then statement. So we'll use an arrow to represent the conditional. The statement, if not P, then not Q, is what we'll be making a truth table for. So, how do we start our truth table? Well, we only have two simple statements, a P and a Q. So, we'll have 4 lines in our truth table corresponding to the 4 different ways we can combine truth and falsity for P and Q. The last column in our truth table will show the symbolic representation of our sentence. Now what we need to do is come up with some columns in between to show the parts that we put together to make that final statement. One of those parts is not P. Since we don't have a column for that yet, we'll put a column in for not P. To find the truth values for that column, we'll have to use our negation table. And since we're trying to negate P, we'll look back at the P column and simply find the opposite of each of the truth values in each row. So all the trues become falses, all the falses become trues. The next part we see is not Q, so we'll need a column for that as well. And since that's also a negation, we simply need to look back at the Q column and negate each of those truth values to get the truth values for not Q. Now finally, we need to find the truth values for this conditional statement. If not P, then not Q. So the 2 columns we'll be looking at are not P and not Q. Not P is the antecedent, the if part of our conditional, and not Q is the consequent, the then part of our conditional. So in the first row, we're looking at if false, then false, which according to our conditional truth table we'll evaluate as true. We'll do that for every row. For the second row, we have if false, then true, which in our conditional truth table we can see evaluates to true. In the third row, we have if true, then false, which will evaluate to false. And in the fourth row, we have if true, then true, which evaluates to true. So now that we've got the truth values for our statement, if not P, then not Q, let's go back to the original question we had, which is, how do we know whether that statement, if I can't get a loan, then I won't buy a car, is true or a lie? Well, if we look at the truth values in that solutions column, we can see that the third row evaluates as false, which means we do have a case in which our statement is a lie. Now, when does that happen? Well, look back at the values for P and Q in that third row. P is false, Q is true. So that means the statement we started with is a lie if P is false, so I don't get a loan. And if Q is true, so that means I buy a car, is a true statement. So, looking back at our statement again, if I can't get a loan, then I won't buy a car, is a lie if what really happens is I don't get a loan, but then I do go ahead and buy a car.